I'm so glad you joined me in looking at how to solve an exponential equation where I not only have two terms with the exponential expressions, but I also have a constant term. So when we look at this particular equation, I see how I have an exponential expression in the first term on the left-hand side, also in the second term on the left-hand side, but then I have a constant term on the right-hand side. So the previous videos that we looked at would not have methods that would help me to solve this equation. I do, however, notice that one of the bases here, 49, can be written as a power of the other base. So 49 is actually 7 squared. So I can write this as 7 squared to the x minus 4 times 7 to the x is equal to 12. Now recall from our properties of exponents that if I have an exponential expression to yet another power, to simplify that I keep the base and I multiply the exponents. So that means my first term is 7 to the, 2 times x is 2x, minus 4 times 7 to the x is equal to 12. Now while they're not like terms, what I can also do in this first term is to realize that multiplication is commutative, and by using that same property of exponents in the reverse direction, that first term can actually be written as 7 to the x quantity squared. Now we're getting somewhere, because now I have that 7 to the x expression in not only this first term that's quantity squared, but also as a factor in this second term. So since we have that showing up in a couple different places, let's make a substitution to see if it helps us. Pick a letter that's not in this equation. You can pick whatever letter you like. I'm going to pick U. So we have U is going to take the place of 7 to the x. Now making that substitution, we get U squared minus 4 times U is equal to 12. Now we see that this is quadratic in U. And remember, solving quadratic equations we can solve by factoring if it's factorable, and then also by completing the square or the quadratic formula. I have a feeling this might be factorable, but remember, to solve by factoring we need a 0 on one side of the equation. So we first need to subtract that 12 from both sides. And then because my lead coefficient is 1, I just need to concentrate on the numbers who multiply together to give me negative 12, the constant term, and would also add together to give me negative 4, the middle coefficient. Well, those numbers are negative 6 and positive 2. So this factors as U minus 6 times U plus 2. Setting each factor equal to 0, U minus 6 equals 0, or U plus 2 equals 0. So U is equal to 6, or U is equal to negative 2. But our original variable that we're trying to solve for is x, so we need to make that substitution back in. Well, U really is 7 to the x, and then solving for x we can use the natural log of both sides. So the natural log of 7 to the x equals the natural log of 6. Use our property of logarithms, which has us bring down the exponent. So I have x times the natural log of 7 is equal to the natural log of 6, and then dividing both sides by the natural log of 7, I get x is equal to the natural log of 6 divided by the natural log of 7. Now this other possibility says that x to the 7, this exponential expression, is equal to negative 2. Well, remember, that can't be true. The exponentials have a range that are greater than 0, so that wouldn't equal negative 2. So our solution to this equation is x is equal to the natural log of 6 divided by the natural log of 7 to give it in its exact form. Now certainly you could also get an estimation, but we are going to leave our answer exact. Well, I hope you found this video helpful, and check into other videos in the future for more investigations on the topics in our tutorials.